Hi friends, welcome back to yet another session on operating systems. We are into our third module where we had seen how the processes can be synchronized, and now we want to see what the deadlock is in detail and how they can be prevented, avoided, and all that, how they can be tackled with. So let's get into the deadlocks. So deadlock is a situation where the whole thing comes to a complete halt, and for doing so there are four necessary conditions, and all four conditions should be satisfied simultaneously. Only then there is possibility of deadlock. First, mutual exclusion. That means the resources are allowed to share, so more than one process can use the same resource, and we must ensure that race condition should be avoided, and for that we must ensure that any given time only one process should be using the shared resource, not more than one, and that is what we call mutual exclusion. So that is one culprit among the four which can cause the deadlock situation. Second one is hold and wait. A process can request for some resource, and if that resource is available it will lock it, and after locking some resources it will ask for some other resources, and if some other resources are not available then it will wait. But the problem during this wait is the resources which this process was holding already are with that process, and till that process releases these resources cannot be used by others. So hold and wait is the second problem we have, for which it may be possible to lead to deadlock. Third is no preemption. That means the process will have to stop by itself when it feels that its work is over. Only then it will come out of the running state. The external, like operating system, kernel, or any other process cannot stop any running process, so there is no preemption possible, and then this is what can happen. And mainly circular wait is the fourth culprit. One, mutual exclusion. That means one process is using a resource and that resource cannot be used by any other process. First problem. Second, a process is allowed to hold some resources, and if other resources are not available then it will be waiting for the other resources to be available, and till the other resources are available this process cannot continue, and hence it will not complete its task, and hence it will not release the already holding resources. So that is the second problem. Third one, there is no preemption. That means the process has to complete its task, only then it will be stopping its execution. From outside, even the scheduler or any other thing cannot stop the process, and that is next problem. And the fourth one is circular wait. So let's look at what all these things mean. So we have a situation here where we are working with two processes, P1 and P2, and we are having two resources, R1 and R2, for our current explanation. Just assume a simple system, two processes working with two resources. Both the resources are shareable, and assume that the process P1 has already acquired the lock of resource R1. That means R1 is assigned to P1, and R2 is assigned to P2. That means P2 has acquired the lock for R2. So to start with, R1, R2 both were free. P1 said, I want R1. R1 was free. Okay, R1 given to P1. P2 said, I want R2. R2 was free, so given to P2. After getting R1, now P1 demands, I want R2. But R2 is already given to P2, so R2 cannot be given to P1 because of mutual exclusion. If R2 is with P2, it cannot be with P1 also. Therefore, because of mutual exclusion, P1 has to wait till R2 is released, and that has to be done by P2. Now, unfortunately, P2 wants R1. Now P2 requests for R1, but R1 is not free because it is already assigned to P1, and again R1 mutual exclusion can be assigned to only one process, so it is already assigned to P1. Therefore, now P2 has to wait for R1. Now what is happening? P1 is waiting for R2, P2 is waiting for R1, and not just waiting, it is holding R1 waiting for R2, that is P1. If you look for P2, it is holding R2 and waiting for R1. So hold and wait. Third, there is no timeline, there is no maximum time or something like that for which any process should complete its job and all that. So there is no deadline given to any of these processes. So these processes can run as long as they wish to, and there is no preemption. What is happening? P1 having R1 waiting for R2, P2 having R2 waiting for R1, and if you look at it, we find a circle, so that is there is a circular wait. So P1 waiting for R2, P2 waiting for R1. R2 is not available because it is with P2. R2 cannot be released because P2 is waiting for R1. P2 is waiting for R1. R1 cannot be released because it is with P1, and both R1, R2 cannot be released. Therefore, P1 cannot continue, P2 cannot continue, and because of this, we say this is a deadlock situation. So we have a situation where we are having a deadlock. So the same thing we can look at a simple traffic example. So we have here a series of vehicles, and if you can see that all the four lanes are blocked, and unless this moves ahead, this cannot move further. To move this ahead, this has to move, and to move this ahead, this has to move. To move this ahead, this has to move. So if you can see that there is a circular wait, and hence all these vehicles will be stand still forever. So that condition is called deadlock. So that's introduction to deadlock. See more details in the next session. Thank you.